So it's actually really not too complicated. Like, I guess the one thing you might not have known is that if you power a repeater into the side of another, it locks it. So you'll see in a second here. But this is one bit of memory right here. Well, technically, just this repeater is our bit of memory. And then everything around it is control components. And that's why this shit gets so big, is the control components. Because we have obviously our input, our output, but up here we have a write lever. It's not even a write enable lever because over here we have the bank select write, and all this does is allow like this our input to connect through to this repeater. So we toggle that on and we've selected this bit for writing, and then we put a 1 on the bus. Bus is just a wire. But you see how the bit hasn't flipped because it hasn't been told to write. So we just tell it to write really quick and it'll store that. So even if we disconnect it from the bus because we want to write another bit somewhere else, it'll stay stored there. And every time we need to see if it's a 1 or a 0, we just read it and it goes out to the output. Now you scale that up and the bank select starts going into a binary to decimal decoder, or unary rather. This would be unary, um, which means that there's a slot for every number. Like in our counting system, tens based, they're only a slot for tens. So you have your ones, tens, hundreds, thousands. You learned that in school. With unary, there's a first, second, third, fourth, blah, blah, blah. And then the input is binary. So you have one, two, and if you want three, you turn on two plus one and you get three. And if you want four, you turn on four, five, six, and then seven would be these three on. Then 8 would be this place. But this allows you to pick a bank. So if I want bank 1, I would select bank 1, but it didn't come on because I have a chip enable line, chip select line, which is common for modules like this. And what that does is those two pistons that are on the ground right there are vertical here, and that just connected bank 1 to the write and read enable lines. Um, and they'll get connected to the bus as needed. So, like if we read what's in there now, I flushed it, we'll get, oh, I didn't flush it. Yeah, there's a value in there. There's 10101010. Should be hex 55. Um, and so now say I want to write to it, of course you have to disable the read, and then say I want these two on instead of those other four. All I have to do is come over here and write it in. Like you could just press the button too. But now the bus goes quiet, and a couple minutes later, it's like, oh, hey, what was the value I needed stored there? Boop. 2. Well, this would be 3 if, depending on if you're big endian or little endian. It'd either be 3 or like 200. uh, 255 minus 16 plus, no, 32. It'd be, well, yeah, no, it'd be 64 plus 128 if I weren't an idiot. But yeah, and so now like we can even leave it in read mode, and then we could take a look at, if I flip this down, we'll go to bank 3. We've got 4 on and 4 off on 3. And we'll just take a look at bank 2. What does it have in it? All zeros. Let's go ahead and write a value into bank 2. And like normally, the way this will be implemented is nobody will be flipping levers. You'll set up some ROM, which will have a program on it that the computer will be able to run, and it'll just use this RAM itself. Bank 2. So now that value will be written into bank 2. So if we leave this in read mode now, See, bank 2 has those two values, and then bank 1 had those two values, and then bank 3 we had those four in. And what's in bank 4? Just one line. But like we want to turn on another line. See, to do a write operation, it overwrites them all. So we would have to, even though this is on already, we'd have to flip it back on because we're in read mode. And then we'll write that in. And now every time we call up that memory cell, it will output those values. And that's basically the whole idea. And this decoder is really simple in how it works. It basically turns everything on except for the exact selection. So you have to manually go through and like the number, let's go 1, 2, 3, 4, 5. The number 6 would be 4 and 2. So 1 is off, 2 is on, 4 is on, 8 is off. So you get 6. Um, I might be completely redoing this because it's fucking huge and I want it to be smaller. And this causes some bus conflicts because this bus is bidirectional, or is supposed to be, but because of the output, I might have a master output enable that'll fix this, but because of the output, it doesn't actually, this line would need to make it all the way to here, uh, or even all the way to here because this is the write line, write and read line. Like I said, it's all bidirectional. Um, but what happens is if it's not set up this way, this guy during a read operation, if this bit is on in any of these banks and the bank is selected, it will power this on, which will go back here, go up here, and then normally there'd be a repeater here to help with the bidirectionality of the thing because it's a big loop. Um, and that repeater would get powered, then come down here and then power this line, which would power this repeater, which would power, so it can never turn off once it turns on. So I've got to figure that shit out. Yeah, this is like the very tiny beginnings of a hopefully huge project.